All right, trigonometry class, we're going to be looking at section 2.2. We're looking at trigonometric functions of non-acute angles. Remember the previous section we looked at just acute angles. This one covers all other angles. And so the first thing we're going to look at is something called reference angles, and we have to use reference angles in order to find um, uh, this last portion right here, finding angle measures with special angles. So let's first look at reference angles. Okay, so here's what a reference angle is. A reference angle for an angle theta is the positive acute angle made with the terminal side of angle theta and the x-axis. So terminal side is this side right here that is something else other than the x-axis. Okay, all of the acute angles that we looked at previously just use the positive x-axis, and to determine the angle of that, we go counterclockwise, and that gives us our angle. But our reference angle is this right here. In comparison, it's always going to be the smallest angle according to wherever it lies in whatever quadrant compared to the x-axis. So we have our x-axis here. Here is our angle. And then this is our given angle theta. But this right here from where our angle terminal side is to the x-axis, that is our what we call our reference angle. So again, here's something that lies in quadrant 3. Here's our angle right here. And so our reference angle is this right here. And then over here on for quadrant 4, again, this is our big angle right here that lies in quadrant 4. Our reference angle is just this right here. So this is how you're going to find the reference angle. All right, so if you are in quadrant 1, your reference angle and angle theta are always going to be the same. Okay, your reference angle is always going to be an acute angle, something less than 90 degrees. Somewhere between 0 and 90, I must say. All right, and then if you are in quadrant 2, like this angle measurement right here, how you're going to find this reference angle is by saying 180, which this is your 180 degree on XY axis, and minus your theta. So 180 minus theta will give you your reference angle. If you're in quadrant 2, what you do is pretty much the same thing, but we don't want a negative angle. So we take theta and subtract it from 180, and that will give us our reference angle. In quadrant 4, this is our big angle for quadrant 4. How we get the reference angle is by saying 360, because that's this x-axis right here is 360, minus your angle theta that you were given. All right, so let's do an example. All right, so I'm going to be switching back and forth between the previous slide and this one to do and to show you how to do these examples. All right, so for part A, it says find the reference angle for 294 degrees. So 294 degrees is in this fourth quadrant because it's an angle greater than 270. It's between 270 and 360. So to find the reference angle of an angle that is in quadrant 4, what we're going to do is follow this right here. We're going to say reference angle is equal to 360 minus our 294 that we were given. So let's do that. Reference angle, always denote it with that little symbol like this. So 360 degrees minus our given angle, 294 degrees. So our reference angle is equal to 66 degrees. And that's it. That's it on finding reference angles. All right, so next it has us find the reference angle for 883 degrees. Well, this is something much bigger than 360. So to find the reference angle for something that is bigger than 360, let's find its coterminal angle first. So subtract 360 as many times as you want, or as you need, not want, to get this angle, a coterminal angle that is between 0 and 360. All right, so let's do that first. We are going to say 883 degrees. This is finding the coterminal angle minus, I'm going to say we're going to need to do it at least 2 times. Let's see where that gets us. Okay, 2 times 360, 630. So take that, subtract it. We get 163 degrees. Well, that angle is coterminal to this 883, and it's between 0 and 360, so we can stop here. We don't need to subtract 360 anymore. Now, from this coterminal angle, we are going to find its reference angle. So, let's go back over. 163, that angle is somewhere between 90 and 180. So that's in our second quadrant. Okay, so this is what we're going to do to find the reference angle if our angle lies in the second quadrant. Take theta, or take 180 and subtract our angle theta from it. So reference angle is equal to 180 degrees minus 163 degrees. And that gives us 17 degrees. And there's our reference angle. And that's how we do reference angles. Now, we have found the values of 6 trigonometric functions for acute angles before that we've looked at in the previous section. And all of the trigonometric function values that we were looking at of angles that we were given were of special angles. And so these right here are going to be also special angles, or quadrantal angles actually. We consider those special angles too in trig. So first things first, whenever we are finding the values of our 6 trigonometric functions for an angle that is not acute, is find the reference angle first of the angle that you are given. Okay, and remember, I'm going to write down what quadrant this is in. So 225, well, let's go back to this right here. 225, let's see, that is somewhere between 180 degrees and 270 degrees. So that is in our third quadrant. And here's how we find the reference angle. We take theta and subtract it from 180. Okay, so let's go back. So find the reference angle and say our angle given, which is 225, and subtract 180 from it. I'm going to go ahead and state over here. This angle is in quadrant 3 because we got to remember that. for something later in finding the 6 trigonometric function values. All right, so this reference angle is equal to, let's see, 45 degrees. All right, so whenever we go to find the values of our 6 trigonometric function values, what we need to do is, for sine of 225 degrees, that is going to be the same as, well, sine values in quadrant 3 are negative. That's why I needed to remind myself that it's in quadrant 3. So let's say sine of 225 degrees is the same as finding the negative sine of 45 degrees. Okay, so if you can remember, sine of 45 degrees is square root of 2 over 2. So your answer to sine of 225 degrees is negative square root of 2 over 2. Because don't need to forget this negative sign here and place it over here. And that's how you do all 6 of these. Is we're going to do the same thing for cosine. Cosine of the 225 degrees is going to be, again, cosine is negative in this quadrant. So it's the same as finding the negative cosine of our reference angle, which is 45 degrees. And again, 45 degrees, our cosine of 45 is square root of 2 over 2. And then, let's see, tangent of 225 degrees is, now tangent and cotangent are going to be positive in this quadrant. So a tangent of 225 degrees is the same as finding the positive tangent of 45 degrees. And that is just 1. All right, let's go ahead and work our way backwards. Cotangent of 225 degrees is the same as cotangent of the reference angle, 45 degrees. And like I stated, for finding tangent, it's cotangent is going to be positive in this quadrant. Cotangent of 45 is also 1. Now, this solution and this solution for sine and cosine, that's been rationalized. If you remember, this is the same thing as saying 1 over the square root of 2. So finding the secant and cosecant values, just flip 1 over the square root of 2, that becomes square root of 2. So for, secant of 225, it's the same as negative secant of 45, which is negative square root 2. And then same thing goes with cosecant. I'm just going to write that out. Cosecant, not theta, of 225 is the same as cosecant of, well, negative cosecant of 45 degrees. And that is, again, the negative square root of 2. Okay. Okay, so this right here is showing you all the steps pretty much that I just did in the previous exercise. So finding trigonometric function values for any non-quadrantal angle and something that is also A special angle is what we're normally looking at in this section. So all of our reference angles are going to be either 30, 45, or 60. And then we've learned about quadrantal angles before. So here's the first step. First, let me get my tool out, my laser pointer. Step 1, if the angle is greater than 360 degrees or if it's less than 0 degrees, first find the coterminal angle that is going to be between 0 and 360. So add or subtract 360 as many times as you need to get an angle between 0 and 360. Step 2, find the reference angle. Okay, so after finding the coterminal angle between 0 and 360, find the reference angle of that coterminal angle. Step 3, find the trigonometric function values for each reference angle. Okay, and then determine the correct sign for the values in step 3. So that's why you want to know what quadrant your original angle lies in, is so you can find all of your the correct signs for all of your trigonometric function values. Okay, so follow these 4 steps and you'll be good on finding the 6 trigonometric function values for non-acute and non-quadrantal angles. All right, so here's another exercise. We're going to look at find the exact value of sine of negative 150 degrees. Okay, so this angle, negative 150 degrees, is less than 0 degrees. So we need to find its coterminal angle. That's step 1. Find the coterminal angle between 0 and 360. So we're going to add 360 to this. Just like that. And we end up getting 210 degrees. Now 210 degrees, that means these two angles, negative 150, 210, they're the same angle. They lie in the same quadrant. 210, that is between, let's see, 180 and 270. So this lies in the third quadrant. Okay? So we know in the third quadrant, the only thing that is positive, like in the previous example, is tangent and cotangent. So sine of negative 150 or 210 is going to be negative. But next step in finding what sine of negative 150 degrees is equal to is let's find its reference angle. Now for finding its reference angle, lies in the third quadrant, we need to take our angle and subtract 180 from it. So take 210 degrees, subtract 180 degrees, and that gives us 30. So there. See, I told you, all these special angles are going to come about as your reference angles. It's going to be either 30, 45, or 60 degrees. All right, so sine of negative 150 degrees is the same as, is equal to negative sine, because we're in the third quadrant, of 30 degrees. So look up on your chart that you will have in your book, and I will also let you have that chart on your note card. You can go ahead and copy that down if you would like. Find what sine of 30 degrees is, and 30 degrees, that's 1/2. So this answer is going to be negative 1/2. And we're done. Let's look at another example. All right, so step 1 of finding the exact value of cotangent of 780 degrees is find its coterminal angle that's between 0 and 360. So our theta here is going to be 780 degrees minus, subtract 360, 2 times will get us there. And that gives us 60. Well, 60 degrees, we don't have to find the reference angle of that because it is an acute angle. It lies in the first quadrant. The reference angle for something that's in the first quadrant is going to be the same. So we can go ahead and look at cotangent of 780 degrees is the same as cotangent, and it's going to be positive because all angles in first quadrant, or all function values in the first quadrant, are positive. So find cotangent of 60 degrees. Look at that up on your chart, and you should see that it equals the square root of 3 over 3. And we are done. All right, so some of these, if you remember this from the previous chapter, we had some of these problems where you had to evaluate something that looked like this, but all of the angles on the inside of your functions were some sort of quadrantal angle. Now these are going to be some sort of special angle where it's a 45 degree, 30 degree, or 60 degree angle. Well, here, sine of 45 degrees, we're good to go ahead and find that one. The other angles, the 135 degrees and 225, we need to find its reference angle before going and figuring this one out. So, let's do this. I know sine of 45 degrees is equal to square root of 2 over 2 cosine of 135 degrees is equal to, now find the reference angle of that. The reference angle for this one is going to be 45. But remember, we are in the second quadrant, so cosine and a value of it in the second quadrant is going to be negative. So find the negative of cosine of 45. It's going to be square root of 2 over 2 again. And then the last one, 225. Again, this is going to be a reference angle of 45 degrees. But this is in our third quadrant. So tangent values in the third quadrant is going to be positive. So tangent of the 225, we already found that in a previous exercise too, is 1. Now take all of these values that we have found for each of our cosine, sine, and tangent functions and plug them in what you have to evaluate. So this right here, I'm just going to rewrite it. Sine squared of 45 degrees plus 3 cosine squared of 3, or 135, minus 2 tangent of 225. Okay, this right here represents, another way of saying this is sine 45 squared. So in here, sine 45, plug this in. So square root 2 over 2 and square it. Add 3 times the cosine value of 135 degrees, which is, again, negative square root 2 over 2. This is supposed to be negative 2. And then square it. Subtract 2 times the tangent of 225. Plug in this value for tangent of 225, and you've got 1. All right, evaluate this. Leave it in exact form. So you're going to have to add and subtract fractions together. And what this ends up being, so squaring this, you end up with what? 1/2 plus 3 times 1/2, just 3/2. And then subtract 2. And what you end up with, well, 1/2 plus 3/2 gives you 2. So 2 minus 2 is 0. And there we go. That's how you evaluate something like this. Now, some of your homework problems may ask you to evaluate each function by first expressing the function in terms of an angle between 0 and 360. That's the same thing as what we were doing before, which was first step in finding this is finding the coterminal angle, something that lies between 0 and 360 also. So take sine of 585 degrees and express it as an angle that's between 0 and 360. So subtract 360, find that coterminal angle. And that gives us sine of 225 degrees. Now, we have already found sine of 225 degrees on a previous slide. If you look back on that slide, you would see our solution to that was negative square root of 2 over 2, because the reference angle for 225 was 45 degrees. All right, let's look at this part B here. Again, do this step right here, find the coterminal angle to negative 930 degrees. Let's see, cotangent, negative 930. We're going to have to add 360 several times. Let's say 3 times. And that will get us to cotangent of 150. You don't necessarily need parentheses right here. Cotangent of 150 degrees. Find its reference angle, which is, let's see, 30 degrees. And 150 degrees, that is in the second quadrant. Cotangent is going to be negative. So what we're finding here is negative cotangent of 30 degrees. And that gives us negative square root of 3. Okay. So if you're missing how I'm coming up with that cotangent of 30 degrees is the square root of 3, go back to your chart in the previous section, and that is where I am finding those values. Cotangent of 30 degrees comes from that chart, which is the square root of 3. And then we just multiply our negative value to it because it is in the second quadrant and cotangent is negative. All right, let's look at one last thing. All right, so you are going to have a problem to do in your assignment I give to you that is much like this one here. It says find all values of theta if theta is in the interval of 0 to 360. Okay, and given that sine of theta is equal to negative square root of 3 over 2. Well, one of our special angle values is equal to the square root of 3 over 2, and that special angle value is, if you look it up, sine of 60 degrees gives us the square root of 3 over 2. All right, so what we're going to do here is 60 degrees, in this case, is our reference angle. And sine of theta is negative. You have to figure out what quadrant it is negative in. So it is negative in the third quadrant and the fourth quadrant, I believe. Let's see. Yes. So theta, I'm going to say theta must be in quadrant 3 and quadrant 4. Just kind of keep this here as a reminder. Now, if our angle here for sine to equal this right here, we know it's 60 degrees. That's how we come up with our reference angle. It's 60 degrees. This is how we are going to find what our angle theta is in quadrant 3 and quadrant 4. Okay, so for quadrant 3, let's see, quadrant 3. How we find this out, usually to find the reference angle, we subtract 180 degrees from our original angle that we're getting, our theta, but instead of subtracting, to find our angle, we are going to add 180. So take our reference angle that we are given and add 180 degrees. So we found our reference angle to be 60 degrees, add 180. So in quadrant 3, our angle that is going to give us negative square root of 3 over 2 is 240 degrees. There's one of our solutions. In quadrant 4, our angle theta, how we usually find our angle, our reference angle that is in the fourth quadrant is take 360 and subtract our 60 degrees. Well, in this case, we do the same thing. We take 360, subtract our reference angle, which is 60 degrees. I'm going to write that down. Reference angle first. So 360 degrees minus 60 degrees is 300. So our quadrant 4 angle, 300 degrees, which makes sense. 300 degrees lies in quadrant 4 and is a reference angle of 60 degrees, or has a reference angle of 60 degrees. So if we plug in sine of 300 degrees into our theta, we should end up with this negative square root of 3 over 2 as our solution. And there are ways of checking that. You can actually plug this straight away into your calculator, and do you get the same decimal answer as this right here? Well, if that's the case, then you have found the correct angle. Okay, so let's see. Oh, we're done. So that is it for this. I hope everyone understood everything. If not, then please ask me as many questions as possible whenever we get back to school. So I'll see y'all later. Goodbye, everybody.